Okay, this is a pretty tedious problem, but I'll go through it real quickly and then you can pause the video and take a look to see where perhaps your mistake is. We're going to use these following summation formulas, which I've rewritten down here by multiplying everything together. We're going to substitute those values when we find the limit. Since we're going from, oh, by the way, here's proof that your answer is correct. 106.5 is what we're looking for. Since the intervals from 1 to 4, the width of n equals subintervals, each one is 4 minus 1 over n, or 3 over n. I'm going to set this up with the right-hand endpoints. Might have been better to use left-hand endpoints, but I used right. So x sub 1 is 1 plus 1 width, and x sub 2 is 1 plus 2 widths. So x sub I is 1 plus 3i over n, or 3i plus n all over n. Just got a common denominator. So we're going to take that expression and substitute it into f of x to get the height of each subinterval. And that's what we have right here. F of x sub I, put that expression in to the function, expand and simplify. So when we cube this binomial, we'll probably use the binomial theorem. A plus b, the quantity cubed, is a cubed plus 3a squared b plus 3ab squared plus b cubed. That's where all this came from. And over here we squared that binomial and squared the denominator. And to get from here to here, I multiplied top and bottom of this second fraction by n to get a common denominator, multiplied everything out, combined similar terms. I'll leave that to you. But that's the formula for f of x sub I. And if we want to get a formula for the area of the ith rectangle, we have to multiply this by 3 over n, the width of each subinterval. So that's where this came from. 3 times every term up here gives us this. And so there's the formula. And we want to add up all of those rectangles and take the limit as n approaches infinity from the sum of the areas of all those rectangles. I goes from 1 to n. So here's what we go. The limit as n approaches infinity of, well, picture this first term here, and 162 over n to the fourth, and then replace the sum from I equals 1 to n of I cubed of this guy. So we move the 4 under the 162 and the n to the fourth from here underneath this. And I won't go through all of the details, but that's kind of what you end up with, realizing that the sum of 3 over n from I equals 1 to n of 1 is just n. And so the idea is that if you picture dividing this n to the fourth into every term of this numerator, these two terms are going to approach 0 as n approaches infinity. But n to the fourth over n to the fourth is just 1. So 162 over 4 times 1 gives us this number right here. And 135 times this guy. This 2 goes into the 6 3 times. 3 goes into 135 45 times, etc. So there's what you get. And if you add up all those terms, you do indeed get 106.5. Okay. You might have tried something a little different, but pause the video, take some notes, and see if you can see where your mistake was. There you go. Hope that helped. If you have any questions, post a comment.